This research is about the use of Nilotic tilapia oil, Oreochromis niloticus, as a potential substitute to soybean oil on a chicken diet, the effect on meat quality. Objective. The objective of this work was to evaluate the effect of replacing soybean oil with fish oil in commercial diets of broilers regarding meat quality. Methodology. The pectoralis major of the chickens, N equal 40 per treatment, raised in controlled conditions, fed 10 days pre-slaughter with experimental diets STD, basal diet, and FSD, diet with nilotic tilapia oil, were separated, randomly distributed, individually packed in polystyrene tray wrapped with retractable film and restored refrigerated, in simulation of the typical commercial conditions from the Brazilian market, fluorescent lamp. The breasts were removed randomly, N equal 8 per treatment, during 5 days of refrigerated exposure, in order to evaluate the quality parameters: lipid oxidation, pH, cooking loss, loss of mass and texture. Lipid oxidation, pH, cooking loss, loss of mass and texture. Lipid oxidation was quantified using the thiobarbituric acid reactive substance assay TBARS adapted by Vital and contributors. The sample of ground chicken breast from each treatment was mixed with TCA solution homogenized using an Ultraturex and later centrifuged at 4 degrees Celsius for 15 minutes and 4,000 rotations per minute. The supernatant was filtered and mixed with TBARS reagent. The mixture was boiled for 15 minutes, cooled, and the absorbance at 532 nanometers was compared with the MDA standard. The result was expressed in MDA per kilograms of meat. The pH was measured in duplicate at the cranial and caudal lens, using a pH meter equipped with a penetrating pH electrode. The cooking loss was evaluated according to Delizotti and contributors, in which the breast samples were previously weighed, individually packed in polypropylene bags, and placed in a water bath at 80 degrees Celsius and cooked until the internal temperature reached 78 degrees Celsius. Soon after, the samples were cooled and the losses were evaluated as a percentage of the initial weight of the sample. The mass loss was assessed using the methodology described by Honeckell during the storage days, in which the breast was previously weighed and stored under refrigeration, and after the estimated period, the breast was weighed again to assess its loss. The mass lost during storage was expressed as a percentage. The shear force of the breast was measured using a texture analyzer equipped with a Warner Bretzel blade according to Honeckell, and configured with a 5 kg load cell and a crossing speed of 1 mm per second. The mass loss during storage was expressed as a percentage. The shear force of the breasts were measured using a texture analyzer equipped with a Warner Bretzel blade according to Honeckell, and configured with a 5 kg load cell and a crossing speed of 1 mm per second. The breast was cut into rectangular pieces of 1 square centimeter cross-section, 10 pieces per breast, perpendicularly to the fibers. Statistical analyses were performed using SPSS version 21 for Windows. The experimental design was completely randomized with 2 treatments, STD and FSD, in triplicate and 5 storage times, 5 days. The significance of the differences between treatments was made by the t-test and the one of the storage time by Tuckey test at p less than 0.05. Results. According to our findings, oil replacement and exposure time did not significantly affect lipid oxidation and pH. When both effects were assessed, no interaction between them was observed. Weight loss and cooking loss were not affected by treatments. However, they were affected by exposure time. Over the days of exposure, the samples showed an increase in mass loss and a reduction in cooking loss. When evaluating the effects of both factors, treatment versus exposure, the factors did not show interaction. It can be seen that the replacement of the oil did not affect the quality of the meat, showing that this possible modification is an important issue for the poultry industry. Conclusion. The results of this study showed that replacing soybean oil with Nilotic tilapia oil 10 days before slaughter does not affect the quality of chicken meat. Considering that soybean oil has substantial costs and that Nilotic tilapia oil is a growing byproduct in processing industries, a better understanding of these substitutions opens up a promising opportunity for the Nilotic tilapia destination with reduction of costs for the poultry industry.